Hey, welcome to 5-3. This is the lesson on rates. A rate, in general, is the quotient of two quantities with different units. So you can think of lots of different rates, and you can think of rates that might be what we call a reciprocal rate. So if you were thinking about a trip, you might think of it in miles per hour. And you also, if it was very slow, perhaps you might even think of it in hours per mile. So the kind of rate you use may depend upon the circumstances. And the calculations here in the examples show you those various kinds of rates and how they might appear. So we'll take you through example like example 1 and something like example 2. Pay attention to the piece about reciprocal rates. I already mentioned it. It's worth mentioning again that the rate units can be reciprocals of each other, and you want to pay attention to how they go together. We have a little bit on negative fractions. We've been through this, so you've seen this before, that it doesn't matter how we write it. As long as b doesn't equal 0, then we can see that any one of these is the same thing. We also have a negative over a negative is a positive. Division by 0, we can't do it. It's not allowed. There's a discussion here about how it just doesn't even make any sense when you look at rates, and perhaps helps us understand why we wouldn't do that. Guided example 3, I'll get you the answers for that, and then I'll be going through another example that's similar to it. And at that point, you're into covering the ideas and applying the math. You'll see that a lot of the problems in here are in context. They're about specific situations. And as such, you'll need to pay attention to how it goes together. Keep in mind, if you set up your equation and the units work out, you're going to get to the right answer. If you set up your equation and the units don't work out to give you the right answer, then your answer is wrong. The units have got to work out correctly. And they've got to be in the right place. You can't just move them where you want just because you want to. They have to be there because that's where they're supposed to be relative to the value associated with the rate. I think some of this will be clear as we move on with this, but do watch out for your units, and I'll see you on the examples. 5-3 extra examples. I'm going to go through a couple of examples with you. Then I'll go through the guided example, and then I'll go through some more examples to kind of cover the various topics. First one up, example 1. In a job interview, Matthew has to take a typing test. In 6 minutes, Matthew types 270 words. The job is his if he can type 55 words per minute. Will he get the job? What is his average number of words per minute? Two questions. The first one needs to be answered second, and the second one needs to be answered first. We need to know what his average number of words per minute is before we can answer the question of will he get the job. Let's go ahead and calculate that. We're going to decode this. What is his average number of words per minute is our equal sign. That means that whatever we're going to do is going to equal words per minute. That's our units of whatever's going to happen over here. So what we have is 6 minutes. Matthew types 270 words. So I need to do something on the left side of the equal sign that will give me the same units as I've written down here on the right side. If I do that, I can calculate whether what his average is, and then I can figure out if he's going to get the job. So minutes has got to be in the denominator. Words has got to be in the numerator. I have 6 minutes. That goes with the denominator. I have 270 words. That goes in the numerator. And so now I have 270 words, 270 over 6 words per minute. Words per minute. Looks like I got something I could calculate. So 270 divided by 6 equals, and we have an answer. That would be 45 words per minute. We've answered part 2. Now we know the answer to the first part is no. He will not. That's example 1. Use the units to help me figure out how to set up my rate to get the answer that I was after. That told me what to do in order to get the correct result. Look at our next example. If a car accelerates from 10 to 60 miles per hour in 45 seconds, write the change of speed in miles per hour per second. Okay, so the change in speed is what we're looking for. Change in speed, and I'm looking for miles per hour second. And what do I have? I know he from 10 to 60 miles per hour. So the change in speed is how much he changed. So the change is 60 minus 10 miles per hour. And that's all divided by 45 seconds. Miles per hour per second. So that would be 60 minus 10 would equal 50 over 45 miles per hour second. I left the R out there. Back to the calculator. Suppose I could simplify it, but 50 divided by 45 equals, that's about 1.1 miles per hour per second. So about 1.1 miles per hour second. That's our increase in speed going from 10 to 60 miles per hour in 45 seconds. Let's take a look at another one. And this is a part B for this same problem. If the car deaccelerates from 90 miles per hour to 55 miles per hour in 10 seconds, what is the change of speed in miles per hour per second? So our change was, we were at 90, so what we ended up with minus where we were, and that was miles per hour divided by 10 seconds. Miles per hour per second. So 55 minus 90 is a negative 35 over 10 miles per hour per second. And I can simplify this just in terms of decimal form to make it a negative 3.5 miles per hour per second. We could also describe this as a decrease of 3.5 miles per hour per second. So we've got the two results. You'll notice that in both cases I've put the ending point and subtracted from it the beginning point. Subtracted the end speed, we took the end speed and subtracted the starting speed from it. So where we finished minus where we started will give us the difference and get the direction of this negative sign correct. All right, for this next section, this is example 3 for 5-3, the guided example. For what values of x is x over x plus 4 undefined, and then for what values of x does x over x plus 4 equal 0? Well, for when it's undefined, it's basically asking us is whenever its denominator of the fraction is 0. So when the denominator is 0, then it's undefined in our algebra. So x over x plus 4 is undefined when x plus 4 equals 0. So we take x plus 4, we can solve the equation, and we get that x equals a negative 4, resulting in 0. Therefore, x over x plus 4 is undefined when x equals a negative 4. Part B of this is asking for when the fraction is equal to 0. And that is true whenever the numerator is equal to 0. So the numerator in this case is x, so when x equals 0, then the fraction is equal to 0. So therefore x over x plus 4 equals 0 when x equals 0. That's our guided example. Take a look at the next example I did on Sketchpad, which was an additional example 3. It is similar to this one. I worked it out a little bit more so you can see just what has to happen to get to the answer we're looking for. Your assignment is to do the covering the reading and applying the math. Take a look at the next couple of examples and then get on with it. Example 3. And for example 3, this is similar to the guided example 3 that we went through in the book. For what values of x is x plus 2 over x minus 3 undefined? Well, when it says undefined, what we're looking for there is for what values is x minus 3 equal to 0. So for part A, what we want to find out is when x minus 3 equals 0, I add 3 to both sides. X plus 3 minus 3 equals 0 plus 3. 3 minus 3 is 0, so x equals 3. What we know is if x is 3, then x minus 3 is undefined. Now that's different from the question of for what values of x does x plus 2 over x minus 3 equals 0? Well, that's only true if the numerator equals 0. So for part B, here we want to find out for x plus 2 equals 0, what does x equal? Subtract 2 from both sides. 2 minus 2 is 0, so I have x equals 0 minus 2 is a negative 2. And I know now that my answer to this question of when would it equal 0 is when x equals a negative 2. Those are our answers for extra example number 3. Yeah, extra special example. For what values of x is x squared minus 1 over x squared minus 4 undefined? This is a little bit different question. It still leads to the same idea that if this is undefined, that means that x squared minus 4 equals 0. So x squared minus 4 equals 0. I add 4 to both sides, so x squared plus 4 minus 4 equals 0 plus 4. That becomes 0, so x squared equals 4. Well, I want to know what values of x would make this true. So let's see, the square root of x squared is just x, and the square root of 4 is 2. So here I've got an answer that tells me that when x is 2, this is undefined. But isn't it possible that x could also equal -2? And if it did equal -2, would that also make this equal to 0? And so x squared, it would be -2 times a -2. A negative times a negative is a positive. So that would be 2 times 2 is 4. Yeah, it would result in the same thing. So the difference here between this one and what we've done previously is x is squared. And when I took the square root of x, at that point I wanted to get plus or minus 2 as my answer. I wanted to know both the positive and negative values that would make x squared equal to 4. And so my answers reflect those two values. That's it for 5.3. Taking a look at covering the ideas and applying the math. Get ready for the mastery quiz. Bring in questions if you got them. I'll see you in class.